Okay, thank you. Good afternoon. My name is John Bambenek. Despite my name, I apologize. I actually don't speak any Polish, so this presentation will be in English, talking about the promise and peril of machine learning and some lessons that I've learned in my process of using this in my research and some of my threat intelligence work, right? So kind of start with a problem, right? Is that what I call too much issues, right? There's too much malware than we could ever analyze. There are too many security events that we can ever respond to. There's a lot more criminality than there is defenders, right? The last talk was a great example of it, of the rapid growth of ransomware, not just for extorting money, but for sabotage, right? In terms of breaches, people get into organizations, they remain there for months. Often there's actually evidence of those breaches in the logs, and what this means and what I take from this is that if we knew what to look for and had tools to respond quickly, we could greatly reduce the amount of damage caused by some of these attacks that we've been talking about here at this conference, right? So the promise of machine learning, right? Using tools to greatly enhance and automate, if not the response, a lot of the analysis to say, you know what, this is the important thing that I need to respond to right now. These are the priorities. This is just kind of noise. The peril, right? We are automatically analyzing stuff created by criminals, intelligence agencies, and saboteurs, and then potentially making automated decisions about that, right? That should concern everybody when you're taking data and tools created by criminals and making automatic decisions about them. And the solution is what I call multidimensional machine learning, which we'll get to towards the end of my talk. So, the goals is, right, take something previously unobserved, unknown, and make some decisions about this, right? I don't need more tooling to create more signatures or detections about stuff we already know about, stuff that antivirus or my tools or anybody's tools detect. What I'm looking for is things that are new, that are unknown, to make a decision. Is this otherwise previously unobserved thing bad, suspicious, or can I leave it alone, right? So that we're talking about malware, could be talking about host names or domains, SSL, TLS, or digital signing certificates, right? We need data from both things that you can see on the network and endpoint to figure that out, and data points from both. And the idea is basically to create something where I could say, I've just seen this event on my network within 60 seconds. My tooling does most, if not all, of the analysis for me. I can push a button and make it go away. That's ultimately the goal where we need to go. So first, right, SSL, TLS certificates, right, which have a lot of data associated with them, right? And particularly, right, encryption does create some problems for us. If we can't get to the content of a message, right, there's a lot less information I have about that, right? But there is still metadata, the signing or the certificate details presented by a web server, and to an extent also for signed binaries or mobile applications, right? The certificates have a ton of detail that can be analyzed, and you can make some decisions based upon that. I'll show you a detail in a second, right? You could use this to find mobile malware, particularly in Android. I know Google is using a form of this where it's now much more difficult to actually get mobile malware in the Google Play Store. Third-party stores, that's a very different thing. But just based on signing certificate details and permissions wanted for mobile apps, you can make a lot of good judgments with machine learning of what's malicious, what's suspicious, and what's safe. Here's an example of a certificate, right, created by a mobile malware builder that has some data. You see validity dates. A 27-year validity for a certificate, right? That's pathological. People pick 1 or 5 or 10 years. 27 is very odd, and certainly with the month and day being different between start and expiration, right? That's not something that organically occurs. Cincinnati, Oregon, isn't actually a city in the United States, and certainly it's not in the European Union. I can see all of this by my eye and what I know about US geography, I could say, this is wrong, this is obviously false and deceptive. I could say this is suspicious, and I can do that in an automated way. Domain classifier, right? Taking some new DNS information, right? A host is resolving this host name. You know, can I see if there's something suspicious about this, right? The very easy form of this is doing domain generation algorithms and machine-generated host names, right? You could see it with the human eye. This is nonsense. No one would ever use this in the real world. So I can tell, hey, something is programmatically generating this domain name, which lets me know, have a criteria for suspicion. It's not sufficient, right? But you can do this for any number of attributes. All domains also have registrant information, usually available in whois, so I can look at those details. I can look at the name servers involved. I can do IP reputation for the IPs that it resolves to start looking at other classes of data to inform my judgment, is this domain in fact suspicious? Many of us do this every day in a manual fashion. Machine learning can help us do this in an automated fashion much faster. So as an example, you see these host names in here, right? We can look with the human eye that no matter what language in the world you speak, these domains would never be valid. It wouldn't be somebody would choose. The problem comes in is that while criminals use domain generation algorithms, also ad tracking services do too. So it's enough to say, hey, this is suspicious. I can tell you with machine learning if something is generated in an automated fashion like this, but I need some other data to take me to the next step for maliciousness. A malware classifier or a file classifier. I've got this file that's emailed, I got through an internet transaction, a web transaction, something, right? Antivirus, anti-malware tools are great at detecting already known stuff, right? Is that somebody reverse engineered it, figured out a signature, put it in their product. There's heuristic and other tools as well, right? But it's good for already known threats, right? But it tends to be reactive. There's some proactivity in it, heuristics, which, the first bullet's a little an oversimplification, but this is generally true, right? This is for already known stuff. But I want to detect things before I can have somebody reverse engineer it, or at least get 90% down the road where I can make an informed judgment. Ultimately, what do I prioritize my reverse engineers to work on? They're highly salaried people. I only have a limited number of them. I can't have 1,000 samples reverse engineered a day with a limited staff. But I can use machine learning and some other tools to figure out what features am I looking at, what processes or APIs are called, various things to say, you know what, this does some very suspicious things. To refer back to the previous talk, ransomware has some very defined, specific patterns of action. If I'm looking at the APIs that are called in a system, right, it's enumerating all the files in a file system, applying some filtering, reading, encrypting, writing a file, right? There's a very defined pattern that I can have machine learning trained to say, hey, if I see this pattern, I know something's malicious. Ideally, I can automatically stop it from continuing to execute, where I might lose 5 files or 10 files on a machine, but I will not lose the entire machine, and it certainly will not spread throughout all my network, right? So you can combine that with a lot of things, sandboxing, static analysis, to create lots of metadata for features that you can do machine learning based off of, right? You can figure out what the nearest neighbors are, what are related attacks. A very typical question to ask when you're faced with an attack is, what is the purpose behind this? Is this a nation-state attack? Again, because it's a great example, because it's going on right now, the ransomware attack in Ukraine, right? Is this sabotage? Is it criminality? One very important data point is, have I seen things that I can relate and correlate to the attack that I'm seeing right now? Have I seen that in the past? And that context will greatly inform the attribution that a lot of people want to get to right now. So we need lots of attributes to make this work, right? Lots of metadata, and ideally multiple classes of things, right? So in short, right, I say we need all the metadata, right? From network and from hosts, right? I can do domain classification and TLS on the network. I can't really do a file classification on the network, certainly not if I want to see API calls, right? So you need a variety of different vantage points to make this work, right? A lot of times the metadata is not actually in the packets transiting the network for a variety of reasons. An encrypted session may be one. A file may come down in a TLS session. You will see that in the clear on the host. Domain registration data also is very important. That's, pivoting off to whatever, who is tool you're using or domain tools to say, who is the registrant for this domain? One great simple data point to figure out if a domain is suspicious or not is if it's been registered within 30 days. And now that you're seeing it on your network. Very often we don't see new domains actively being used right away because somebody has to develop some infrastructure, a website, email server, whatever. If something's new, an attacker, when they register a domain, they're immediately operationalizing it. So it's a very great indicator that you don't even really need machine learning to do. It's just, I'm checking one data point and making a judgment, right? And many objects also have child objects. Stage 1 droppers will call other malware that will have its own attributes as well. What could go wrong, right? The problem involved with this kind of analysis is that attackers, both criminals and nation states, know what our inputs are. They know what we're analyzing. As an example, with WannaCry and the kill switch domain that I'm sure everybody knows of, there were other criminal groups who decided to have fun with us and just statically modify the kill switch domain and then start submitting things to VirusTotal just as a way to troll and manipulate security researchers. And we saw that happening in real time, right? And all that involved was going in a hex editor and changing the kill switch domain by hand, right? So they know we're looking at firewall logs. They know we're looking at DNS. They know we're looking at malware. And if we're using that information to make automated decisions, there is a great deal of risk to be had there, right? Because the attacker controls the inputs. As an example, here is a malware config for Dark Comet, right? Commodity rat. The third line, for those in the back, is domain, which is the configuration item for where the C2 is of this rat, and it's pointing to 8.8.8.8, right? Which is Google's Anycast DNS resolver, right? Criminals know that we're looking at malware configuration, and if you are blindly taking that and putting that into a firewall, you've just blocked Google's DNS. You can create a lot of great problems for yourself if you're looking very superficially at only one class of data, right? DGAs as another example, right? You saw from a few slides back. They will never organically appear like that in the wild. You know they were automatically generated by some algorithm, right? If a system beacons to a DGA domain, right, you could say, hey, that's suspicious. Let's go take a look at that. That's okay, right? There's no automation there yet. If a sandbox run, you're running a binary into Cuckoo and you see a bunch of DGA domains, right? You could say, let's reverse engineer that and see what's going on. Okay, valid prioritization, but if you take DGA domains, resolve all of them into IP addresses, and then automatically put those IP addresses into your firewall, that's bad. Because the attacker knows their DGAs, knows their domains, and if they know that you're resolving IP addresses based on them, they can register a domain and point it to anywhere they want. And I also produce DGA feeds, which is a different topic entirely, but I know that criminals have tried to manipulate my feeds because people take those IP addresses and put them into their firewalls, and it causes great damage, right? As an example, for those who don't recognize the 13 IP addresses on this slide, those are the DNS root servers for the internet. If you put those 13 IP addresses in your firewall, your internet is done, right? You have no DNS globally. So if you're taking IP addresses that attackers have in DGA domains and they put those in there, right, you could be knocking out your entire internet. That is a very dangerous thing that can happen. A crafted example, but a crafted example of something I have seen in the wild actually happen. All right? N-gram analysis or bigram analysis, looking at the frequency of how often two letters occur together, is great for identifying machine-generated host names and domain names. Very simple. There's lots of projects out there on GitHub to do this. Doesn't do very good with word list EGAs because they're actually using words to create host names. Right? Word list EGAs are very language specific. The examples I'm thinking of that I've seen use English words, but you could do it with any word you want. The problem comes in with a couple of other aspects is that advertising networks will use machine-generated host names, often to evade ad blocking software. So for a very similar reason that criminals use host name or domain generation algorithms, so do ad tracking networks. I need something else before I make an automated decision, otherwise I'm creating bad outcomes, right? If you're in an enterprise network, you block ad tracking networks, probably not a big deal. If you put those IP addresses in a firewall and spin up an incident response based on just ad tracking, that is a huge waste of time, and eventually people will stop using machine learning if you don't do it correctly. And of course, you have a problem with non-Latin languages in domain names, where you may artificially trip things if you're not being careful with your linguistical analysis, right? You need something else than just doing machine learning on that solitary class of data, right? To do this correctly, right, you need to start with known good and known bad data to train classifiers, right? Which is a very hard problem. I can do it with domains easy enough, right? But there really isn't a good repository of bad TLS certificates, right? That has to be generated by hand and renewed by hand. There's lots of ambiguous data out there. Many exploit kits, for instance, use compromised websites, right? It's definitely exploit kit behavior, but throwing things into IP block list based on that, well, it's compromised. It could be legitimate later, right? There is border cases because there's going to be the need for human judgment somewhere in the chain to say, hey, what should I do about this? There's also often no good whitelists or blacklists. And if you think about this, how would you go about creating a whitelist of known good IPv4 addresses? All right, the 13 root DNS servers, 8.8.8.8, maybe some public infrastructure for your corporations, and beyond that, it gets very hard, right? There's no good way to automatically generate that to post-filter things when machine learning makes mistakes, right? And even with domain lists, right? You can use the top Alexa 100,000 domains globally, but there are some malicious domains involved in there, right? The no IP dynamic DNS, most of the dynamic DNS providers, not just no IP, are in the Alexa top 100,000. But there are a ton of malware C2s that use dynamic DNS, right? You should never whitelist that domain. So it is a very difficult problem of just creating whitelists to create, to basically sanitize data if you're analyzing only on one class of data, right? Oops. So this way, it, suggests, right, cross-functional metadata is a solution. There's limitations of what can be done on the network. There's limitations that can be done with just one type of data, right? You can automatically enrich. So I see a domain. I'm also getting who is metadata from domain tools or whatever provider you are that has registration dates, looking for fake addresses or fake phone numbers, where I can do machine learning not just on those two classes of data, but on how they relate with each other, right? If you store that, you can figure out an alert after the fact, depending on how long you store it. With machine learning, it's hard to do it in line. You've got to do it retroactively. Getting an alert 5 minutes after the fact is better than not getting an alert at all, right? Because you don't really just want to process things as observation. You want to post-process them. Okay, I've seen all these DNS requests. Now I want to get the metadata off the DNS requests, go out to domain tools, go out to whatever you're using to enrich it, and then say 5 minutes later, all my processing is done, this was bad and somebody should take a look at it, right? And moving towards what I call multi-dimensional machine learning. When you look at IP addresses or domains or files or TLS certificates, none of this exists in a vacuum with each other. It is all related. You can do machine learning on each of these classes, but also on the context in which they appear, right? Malware doesn't exist in a vacuum. It got there somehow. That will give you data. But all of these events are part of a larger context. If you're looking at that context, you're self-cleaning your data to be assured that you're not generating a bunch of false positives. So you could try to automate all the defensive cybersecurity, but there's no good whitelist. You could use machine learning to automate 90% of stuff, right? Which is a very good thing to do, so that all your SOC needs to do is do a thumbs up or thumbs down. And you can automate and remediate in seconds, right, once that alert has been generated.